This is section 1.1 and 1.2 notes. We're going to start off with some vocabulary terms. The first one that we're going to talk about is inverse operations. Inverse operations are operations that cancel out. Kind of in short. And the way to kind of think of this is if I have a number, let's say 5, and I add 3 to it, how do I undo adding 3? I subtract 3. So these are inverse operations because they kind of quote-unquote cancel each other out. Another set of inverse operations is multiplication and division. If I have, let's say, 5 again, and I'm going to multiply by 3, the way that I undo that, if you will, is I divide by 3. So those are inverse operations. Inverse operations being plus and minus, multiplication and division. Mean. Mean is a term that's used quite a bit in math, especially in probability and statistics types math. The mean is the average of a set of numbers. And the way that you find that is you add all terms and divide by the number of terms. Okay. Like terms, it refers to kind of a variable-esque state, if you will. Like terms are going to be things like 2 and 3 are like terms. Like terms are also things like 4x and 5x. These are things that can actually combine. These are not like terms to each other. Not like. But these are. These are like terms. Perimeter is the sum of all sides. Synonyms for addition, subtraction, multiplication, division. There's some. What this is basically saying is, what other words might we see instead of addition or add? Sorry, we might see things like sum, or we might see plus, like the actual word plus, or we might see something like increase. Subtraction, we might see things like subtract. We might see in opposition to plus, minus. Less. You might see the word less. Difference. Difference you'll actually see quite a bit. And those are kind of the more common ones. Multiplication, you might see multiply, you might see multiplication, you might see product. You might even see the word by. And you might see the word times. Last one that we have is divide or division. We might see things like quotient or goes into. So those are just some kind of terms that you may see. As we go through Algebra 1, you'll kind of start to learn some of those terms, and you might pick up a few extra ones as well. Now we're going to get into the actual notes part of it, kind of the more mathy side of things. So starting off with number 1, we have this expression x plus 2 equals 5. And what we want to do here is we want to isolate our variable being that letter or symbol that doesn't have a numerical representation to it right off the bat. So I want to get this x alone. This x needs to be alone. And the way that I do that is I need to get rid of this plus 2. And we were just talking about it a little bit. What we're going to use is we're going to use some inverse operations. And so how do I get rid of adding 2? Well, the way that you get rid of adding 2 is you subtract 2. Now, you may have heard this in earlier math. If not, that's completely fine. But there's this idea of what we do to one side, we need to do to the other. So if I subtract negative 2, or if I subtract 2, from this left-hand side, I also need to subtract 2 from the right side. So what that leaves me with is x equaling 3. And we'll do a few more, so hopefully you kind of get the hang of this. But again, what we're doing is we're looking at this and we're saying, okay, how do I get rid of this plus 2? The opposite of plusing 2 is minusing 2. And so that's how we get that answer. Now, good practice is to check your answer. So I go x plus 2 equals 5. And I'm going to plug in this 3 anywhere that I see x. And a lot of times I like to put this in a parentheses just around it, just in case there's a negative or something out here that's going to be changing some stuff. So I go 3 plus 2 equals 5. Nothing near the 3, so I can go 3 plus 2 equals 5. And so I get 5 equals 5. Okay. We're going to go on to number 2. So again, we're trying to get this variable, this letter or symbol by itself. So what I want to do is I say, I want to get rid of this minusing 4. So the opposite of subtracting 4 is adding 4. And what I do to one side, I have to do to the other. And I say, okay, g equals 7. And I didn't say this in the last one, but the way that you know that you're done is you say, is my variable by itself? Is the variable I need by itself by itself? And the answer in this case is yes, the g is by itself. So I say, okay, because g is by itself, there's no negatives, there's no numbers, just only g, that means I'm done. And so now I'm going to check it. So I'm going to go g minus 4 equals 3. Now instead of g, I'm going to write the number 7 minus 4 equals 3. Nothing near the 7, so I can write it by itself. 7 minus 4 equals 3. 7 minus 4 is 3, and that equals 3, and that checks out. Okay. Number 3 has 2 parts to it, which is a little different from what we did in 1 and 2. We kind of have some of these multiple parts now. So whenever we do this, it's important to realize in what order that we should go in. You may remember from previous math the order of operations that we would do. In previous math, we'd use this acronym, PEMDAS. And you might notice, please excuse my dear Aunt Sally, and what that told you is the order to go in, parentheses, exponents, multiplication, division, addition, subtraction. In algebra, whenever we're solving for a variable, we're not going to use PEMDAS. We're actually going to use kind of it going backwards. So I call it SADMAP. And so I say, okay, is there any subtraction that I need to take care of? No, there isn't. Is there any addition that I need to take care of? And the answer is yes. I need to get rid of this plus 7. So what I'm going to do is I'm going to subtract 7 from both sides. Now where this is important to realize is I'm subtracting 7 from the left side right here. I'm not specifically taking it like right off of this h over 2. I'm already taking 7 off this left side, and I'm taking 7 off this right side. So that leaves me with h over 2 equals 3. And so I go through my SADMAP, and I go, okay, is there any subtraction left? No. Is there any addition? No. Division? Yes, there is. This h over 2, this is actually division. So the opposite of dividing by 2 is multiplying by 2. And what I do to one side, I have to do to the other. So h equals 6. Now I go and check it. I say, okay, I have h over 2 plus 7 equals 10. And so I get 6 over 2 plus 7 equals 10. There's nothing near the 6, so it's 6 over 2 plus 7 equals 10. 6 divided by 2 is 3. Plus 7 equals 10. 3 plus 7 is 10, which equals 10. Number 4, we have 7p equals 28. And I wrote this in there. I didn't realize I didn't erase it. But what this is this if they're right next to each other like this means there's an implied multiplication. And so I put the little dot in here to say, hey, this is actually multiplication going on. And I ask, okay, what's the opposite of multiplication? The opposite of multiplication is division. And what do I want to get rid of? I want to get rid of the 7. And so I'm left with p equals 28 divided by 7 is 4. And so I plug that in. 7p equals 28. 7 times 4 equals 28. 7 times 4 is 28 equals 28. Awesome. Alright, the next 3 I want you to try on your own. You have m plus 1 equals 8. And then check it. You have 14 equals 9 minus p. Then check that. And then you have k minus 4 over 3 equals 3. And kind of the hint for number 3 is imagine that this top is in its own set of parentheses. Go ahead and pause this video and try this on your own. I'm going to start doing it just so you're not sitting here waiting for this to continue. So hopefully you tried these. What we're going to do is we're going to try and get m by itself. And so what I see is I say, hey, this m has a plus 1 next to it, so I want to do the opposite of that, which is subtract 1. And so I'm left with m equals 7. Now I'm going to check it. I have m plus 1 equals 8. This turns into 7 plus 1 equals 8. This turns into just 7 plus 1 equals 8. 7 plus 1 is 8, which equals 8. Number 2, I have 14 equals 9 minus p. This one's a little weird for 2 reasons. The first is that the 9 minus p is on the right-hand side, not the left like we've been seeing before, and that's totally fine. If you want, you can actually take and you can switch these to the other side, so you could have this read 9 minus p equals 14 if you wanted to. That's not necessary, though. What we're going to do is we're going to start addressing this. Where this is also weird is that we have this minus p, which we haven't really dealt with yet. What you're going to do, and maybe what you did, is you might have added p to both sides. And you're definitely not wrong. P equals 9. Now, if you're kind of using that SAD map, you kind of would get in this repeating thing of they're like, okay, there's a plus p, I'm going to move it back over here, and you keep going back and forth. So what we need to do is we need to kind of break that. And so what I'm going to do is, this is really a positive 14, so I'm going to subtract 14 from both sides, and I'm left with p equals negative 5. Now to check if this is actually the answer, I'm going to plug it in. So if I have 14 equals 9 minus, p. So 14 equals 9 minus negative 5. So 14 equals 9 minus negative 5. Change that to a plus, so 9 plus 5. So 14 equals 14. Number 3, again, like I said, you kind of imagine that this top has its own set of parentheses if you're trying to think order of operations with that SAD map idea. So what we're going to do is we actually want to get rid of this 3, and this is dividing by 3. So the way that we do that is we multiply by 3. So what I'm left with is k minus 4 equals 9. Now it's just a matter of adding 4 to both sides. So k equals 13. So I'm going to check that. I'm going to plug it in. So I got k minus 4 all over 3 equals 3. Instead of k, I'm going to write the number 13 in parentheses. I'm going to kind of come over here. 13 minus 4 over 3 equals 3. 13 minus 4 is 9 over 3 equals 3. 9 divided by 3 is 3, which equals 3. Okay. Moving on to the next one. They want us to solve for our variable. They want us to solve the equation. So what we're going to do is we're kind of use the idea from the warm-up that we had earlier. So what we're going to have is we're going to have 180, or writing an expression first, equals, all of these sizes need to equal 180. That's where I got that from, by the way. 96 plus 35 plus x. Now I'm going to combine like terms. And this 96 and this 35 are like terms. So 180, 96 plus 35 is 131 plus x. Now I'm going to get x by itself. I'm going to subtract 131 from both sides. And what I'm left with is 49 equals x. And I check and I say, okay, yeah, that fits in. And I'm going to plug this into my original equation. 180 equals 96 plus 35 plus x. 180 equals 96 plus 35 plus 49. I'm going to start combining some terms here. So I'm going to get 180 equals 131 plus 49, and 180 equals 180. Number 2, we're going to set up much the same way. We're going to say 180 equals 47 plus x plus x. And where this one looks a little different from what we've done before is we have these two x's, if you will. Well, actually, wait, we have two x's, right? So what we can actually do is we can actually combine these x's. And I kind of just said what it was. It would turn into 47 plus 2x. And that's what this number kind of says. There's two of these. There's two x's in this equation. And so now I can solve. I can say, okay, I'm going to subtract 47 from both sides. And I'm left with 133. And that equals 2x. I want to get the x by itself still, so I'm going to divide everything by 2. And I'm left with 66.5. And so I do a little check. I say, okay, if I have 180, I say that equals 47 plus x plus x. I get 180 equals 47 plus 66.5 plus 66.5. So 180 equals 47 plus 66.5 plus 66.5. 180 equals 47 plus, that is 133. So 180 equals 180. Right. So now we're going to move on to kind of the next level. We're going to move on to multi-step equations. And what this is there's a couple more steps than what we've done before, thus the term multi. In this, there's kind of more than one way to do it. If you are taking this with a live class, you might have seen another way to do this. I'm going to kind of show you the ways that I'm going to approach it. So for number 1, oops, let me erase that. So on number 1, like I said, there's kind of 2 ways to go about this. There's the first way, which I'm going to show you, and then there's another way using the distribution property. So what I'm going to do here is I look at this and I say, okay, this -3 is outside the parentheses, so I want to kind of take care of that. And what this -3 is doing is it's not subtracting, it's actually multiplying. So I'm going to divide by -3. And what that does is that leaves me with, in parentheses, just so you can kind of see it, plus 2r plus 7. And that's going to equal -1. Now I can drop the parentheses, so I'm left with 2r plus 7 equals -1. And then I'm going to subtract 7 from both sides, because I'm trying to get that r by itself, right? I get 2r equals -8. Divide both sides by 2. And r equals -4. Now I'm going to plug that in and I'm going to check it. So I'm going to go -3, 2 times -4 plus 7 equals 3. And normally, I'm going to do that. I always like to try and start with my variable. That way I can check and make sure that I wrote it down right. Now I'm going to fill that in. 2, -4 plus 7 equals 3. And I'm kind of going to try and solve everything in the middle before I try to do anything weird. 2 times -4 is -8 plus 7 equals 3. -3, -8 plus positive 7, or -8 plus 7 is -1. That's going to equal 3. -3 times -1 is 3, which equals 3. Number 2. Again, I kind of want to try and solve everything as much as I can before I kind of deal with much in the middle. So whenever I look at this, I see this 4 plus 6 parenthesis, 7 minus 4, close parenthesis, equals 4. I see this 4 kind of by itself, and I say, okay, how do I get rid of that? And this is a positive 4, so the way to get rid of a positive 4 is subtract 4. And I do that to both sides. Now, one thing that people really mess up a lot of times is whenever I say, okay, subtract 4 from this left side, they want to try to subtract 4 here, and they also want to try to subtract 4 here. Well, you don't do that. Because we're already subtracting 4 from the left side, that's just kind of compounding the issue of making it harder. So subtract 4 from the left of the equal sign and to the right of the equal sign. So what that leaves me with is 6 in parentheses 7 minus m equals 4 minus 4 is 0. I'm going to divide by 6, and I'm left with 7 minus m equals 0. So 7 minus m equals 0. I kind of see the quick way. You might not, and that's totally fine. So I'm going to do the kind of the not quite there, not quite quick way yet. So I'm going to subtract 7 from both sides. That leaves me with negative m equals -7. I have to divide both sides by -1. And m equals 7. The quick way, in case you're wondering what that was, is you could have been able to see this minus m right here and just added m to both sides, and you'd get the same answer. Alright, so m equals 7, so we're going to do our check. So I got 4 plus 6, 7 minus m equals 4. So 4 plus 6, 7 minus 7 equals 4. 4 plus 6, 7 minus 7 equals 4. 4 plus 6. 7 minus 7 is 0. 6 times 0 is 0. So 4 equals 4. Oops. 4. There we go. Alright, the last two are two word problems. These are kind of a little bit more on that realistic side of things, if you will. So the perimeter of a patio is 64 feet. And remember that a patio, or a perimeter, is all the sides added up. So the width of the patio is 12 feet, and the length of the patio is x plus 6 feet. What is the length of the patio? So we know that the width equals 12. And the length equals x plus 6. A perimeter, like I said, is all the sides added up, and it's not expressly said in this, but I'm guessing we're just supposed to assume this patio is a rectangle, which means it has 2 widths and 2 lengths. So the perimeter is the length plus the length plus the width plus the width. Now, before I even plug anything in here, I'm going to try and kind of simplify this. So the patio equals 2 times the lengths plus 2 times the widths. Now I'm going to start plugging stuff in. So the perimeter I know is 64 feet. 2 times the length, which we said is x plus 6, plus 2 times the width, which we said is 12. Now I'm going to try and start solving this. So I get 64 equals 2, x plus 6. 2 times 12 is 24. I'm going to subtract 24 from both sides. And I get 40 equals 2 x plus 6. Now I'm going to divide both sides by 2. And I get 20 equals x plus 6. And I'm going to subtract 6 from both sides. And I get 14 equals x. Now this is not the length. And that's really tempting to be like, oh, I got the answer here. This is the length. The length is actually x plus 6. So the length of this is actually 14 plus 6, which, if you don't know, is 20. And we can test this too. We can say, okay, our perimeter is 2 times the length plus 2 times the width. So our perimeter of 64 should be 2 times the length being 20 plus 2 times 12. So 64, 2 times 20 is 40. 2 times 12 is 24, so 64 equals 64. Alright, last one. You purchase 2 bottles of sunscreen and a hat. The hat costs $6.50. You pay 6% sales tax. You pay a total of $14.43. How much does 1 bottle of sunscreen cost? So I'm going to assign some variables here. I'm going to call the hat H. I'm going to call the sunscreen S. And we're actually just going to kind of leave everything else as it is. So we know what we bought. We bought 2 bottles of sunscreen, and that's another term that you can use, and 1 hat. We had to pay sales tax, and so there's kind of a little special equation that you can use whenever you're dealing with sales tax, and that's 1 point and then your percentage as a decimal. So in this case, 1.06. and that's going to equal our total, which was $16.43. So, as we go through this, what we're going to do is we're going to divide everything by 1.06. And I did this a little earlier, so I can tell you that 2s plus 1h, I'm not going to do that quite yet, is going to equal 15.50. And I wouldn't expect you to be able to do this in your head, so definitely use a calculator. Alright, so we still don't know the cost of a sunscreen, but we do know the cost of a hat. A hat is $6.50. That's going to still equal $15.50. Now I'm going to subtract the cost of the hat. So 2 bottles of sunscreen equals $9. I divide everything by 2, and I get a bottle of sunscreen is $4.50. Hopefully that answers everything that you have. Make sure you check your teacher's assignments for what you need to do. Have a good one.